Hello, this is Dr. Hanaa Assil, and this is paper 1C. This is Chemistry of Pearson Edexcel, IGCSE, and this was the paper that was done in May of 2020. So this is the summer of 2020. Let us take a look at the questions and discuss the answers. So the first question in this paper was, this question is about chemical elements. Use the periodic table to help you answer this question. So you have at the beginning of the exam a copy of the periodic table, and the first question says identify the element with atomic number 5. Where is atomic number 5? Remember, atomic number is the small one or the big one? Remember that atomic number is the small one in the periodic table, and this is the number of protons. So the atomic number 5, if you look at the periodic table, the atom is boron. This is the one that has atomic number 5. So remember, atomic number is the small number from the periodic table. It is the number of protons in the nucleus of that atom. Then he says, give the symbol of a metallic element in period 3. Where is period 3? Remember that period is the horizontal ones. So hydrogen and helium are in period 1. And then lithium, beryllium to neon, these are period 2. So he's saying look at period 3 and determine a metallic element. So where are the metals in period 3? Remember that sodium, magnesium, aluminium, all of these are metals in period 3, so any of them would be a correct answer. The next question says, identify the element whose atoms contain 14 protons. Again, 14 protons, that means the atomic number is 14. That means the small number is 14. So which one has atomic number 14? That is silicon. Identify the element whose atoms have electronic configuration 2,5. Of course, when we know that the electron configuration is 2,5, that tells us that it is something in period 2, because I have 2 energy levels, and it is in group 5. So where do we have group 5, period 2? So that is nitrogen. Give the name of the compound formed between oxygen and the element with atomic number 13. Which element has atomic number 13 again? That is aluminium. So he's saying if aluminium reacts with oxygen, what is the name of the compound formed? Then that would form aluminium oxide. Remember that something with oxygen will form something oxide. Okay? The position of an element in the periodic table can be used to predict its properties. So he's saying which group in this periodic table contains elements that are unreactive. Remember, where are the elements that are unreactive? You should remember that that is the group we call 0 at the end on the right. Helium, neon, argon, krypton, and so on. These are unreactive, and if he asks why they're unreactive, we say because they have a full outer shell. Okay, which of these is the least reactive element in group 1? If you look at group 1 are the ones on the left of the periodic table. So these are lithium, sodium, potassium, rubidium, cesium, and he's saying which one is what? Which one is the least reactive? Which one is the least reactive? Remember, the one on top is the least reactive. The one down is the most reactive. So you should know that the most reactive metal or the most reactive element in group 1 is cesium, and this is the most reactive metal in the periodic table. Okay, question 2 says the boxes list changes that may happen in a laboratory and the names of some changes. Draw one straight line from each change to its correct name. So if ice turns into water, what is that called? Ice is the solid form, water is the liquid form. So from solid to liquid, that is melting. Solid carbon dioxide turns directly into gas. We said when something changes from solid to gas, that is called what? Sublimation. A solute is stirred into a solvent. When we stir something into a solvent, we said that the solute will do what? It is dissolving in the solvent. So that is a process of dissolving. A student has two solids, X and Y. One of these solids is a pure substance and the other is a mixture. Describe how the student could identify which solid is pure and which is a mixture by measuring a physical property of each solid. How do I know if a solid is pure or not? You should know that if I have a solid, I should measure the melting point. Now, if it is pure, it will have a sharp, specific melting point. If it is a mixture, or we say if it is impure, then it will melt slowly over a range of temperatures. There will be no sharp melting point if it is a mixture or if it has an impurity. Question 3 is about metals. Metals can be arranged in a reactivity series based on their reactions with water and their reactions with dilute hydrochloric acid. The table shows how 4 metals, P, Q, R, and S, react with water and with dilute hydrochloric acid. Now, he's saying identify which of the metals could be gold. First of all, is gold reactive or unreactive? You should remember that gold is at the bottom of the reactivity series. It is unreactive. So gold would be the one that did not react with water and did not react with acid. So that is Q. Suggest why the reaction between metal R and dilute hydrochloric acid was not done. Where is R? He said when he put R in water, hydrogen gas forms very quickly. That means it is very reactive. And if something is very reactive with water, it will be too reactive with hydrochloric acid. So if I put it in acid, it would probably explode. So we did not do that experiment because it would be too vigorous or too reactive, so it may explode. Use the information in the table to place the metals in order of reactivity from the most reactive to the least reactive. Of course, the most reactive would be the one that reacted quickly with both water and acid. The least reactive, we said, is the one that did not react at all with water or with acid. And anything in between will be in between. So which of these is the most reactive? He says R, hydrogen gas forms very quickly, and we did not do the one with acid because that would be too quick or too vigorous, might explode. That means R is the most reactive. Now, which one is the next one? The one that says when he reacted it with water, it formed gas quickly, and with acid, it also formed gas very quickly. So that's the next one, S. And then P, it did not react with water and it reacted slowly with acid, so that is less reactive. And then the one that did not react at all, that is the least reactive. When he tells you to arrange things like this, please notice, is he telling you from most to least or the other way around? Because sometimes he says from the least reactive to the most reactive. So here he wants most to least. Zinc is used to coat iron gates to prevent the iron from rusting. State the name of this method of preventing iron from rusting. We said there are many methods of preventing iron from rusting. One of them is covering the metal with zinc. And we said when we coat the metal with zinc, this method is called what? Galvanizing. So remember that galvanizing is coating the iron with a layer of zinc by dipping or spraying. So we get the iron and either we dip it into liquid zinc or we spray it with zinc. That is called galvanizing. Then another method of preventing iron from rusting. It says state another method of preventing iron from rusting. What were the other methods of preventing iron from rusting? We said painting. So if I have a gate, he says he has iron gates. So one of the methods I could do is painting, or we said covering with oil if we're talking about machines, and we said covering with plastic if we're talking about dish racks. So here he's talking about iron gates, so painting would be another method of preventing iron from rusting. A mixture of zinc powder and copper oxide is heated, and the chemical equation he gives you, zinc plus copper oxide, to give zinc oxide plus copper. State how the reaction shows that zinc is more reactive than copper. Remember, if he asks me, what type of reaction is this? This is a displacement reaction. Now, if we say that zinc reacted with copper oxide and the zinc displaced the copper, then the zinc is more reactive than copper. If the zinc was not more reactive than copper, there will be no reaction. So the fact that the zinc was able to displace the copper to form zinc oxide and the copper metal was formed at the end, that means that zinc is more reactive than copper. Explain which substance is the oxidizing agent. Do you remember what we mean by oxidizing agent? So if I look at this equation, what happened to the zinc? The zinc gained oxygen and became zinc oxide. So the zinc was oxidized. And we said the substance that is oxidized is a reducing agent because it took the oxygen from the other one, causing it to be reduced. So the one that was oxidized is the reducing agent. What about the copper oxide? The copper oxide changed to copper. That is loss of oxygen. Loss of oxygen is reduction. So the copper oxide was reduced, so it is the oxidizing agent. It's the one that gave oxygen to the zinc, causing it to be oxidized. So we said the one that is reduced is the oxidizing agent, and the one that is oxidized is the reducing agent. So he's looking for which one? Oxidizing agent, then we're talking about copper oxide. Why? Because this is the one that lost oxygen. This is the one that gave oxygen to the other one. So we say it is an oxidizing agent. Sodium hydroxide dissolves in water, forming a strongly alkaline solution. Ammonia dissolves in water, forming a slightly less alkaline solution. Identify the ion that makes the sodium hydroxide solution alkaline. When we say that a solution is alkaline, that is because it has what? It has hydroxide ions, OH minus. That is an OH minus ion, hydroxide ion. What is the possible pH of ammonia? Well, you should remember these. We have examples of neutral. We said if something is neutral like water, it would have a pH of 7. Anything less than 7 is acidic. Anything more than 7 is basic. Now, what is ammonia? You should remember that ammonia is a weak base. A weak base means its pH is 8 or 9 or 10 or 11, but not more than that, because more than that, high pH is a strong base, like sodium hydroxide. So sodium hydroxide is a strong base, pH 12, 13, 14. An acid like sulfuric acid or hydrochloric acid would be a strong acid. So that would be pH 1 or 2 or 3. Lemon juice or ethanoic acid, we say they are weak acids. So their pH is 4 or 5 or 6. You need to remember these examples. So ammonia is what? Out of my choices, ammonia could be pH 11. It cannot be 14 because it's not a strong base. And it cannot be 3 or 6 because it's not an acid. When ammonia solution reacts with sulfuric acid, a neutralization reaction occurs and ammonium sulfate forms. How does sulfuric acid act in this reaction? Remember, if I have an acid, what was definition of an acid? We said an acid, if I dissolve it in water, it gives H plus ions. And we said H plus ions is a hydrogen atom that has lost its electrons. So the hydrogen atom has one proton and one electron. So when it loses the electron, then the H plus is just an atom that has a proton. So H plus ions are referred to as protons, and acids are the ones that give H plus ions. So we call them proton donor. A base is something, when I dissolve it in water, it forms hydroxide ions. We just said in the previous question, which ions are formed if we have a base? It is hydroxide ions. Now, the hydroxide ions are things that take the H plus. They react with the H plus. So if we say, what is an acid? It's a proton donor. It gives H plus. What is a base? The base is a proton acceptor, because the OH minus will take the H plus. So here we're talking about acid. It's a proton donor. The diagram shows a beaker containing some ammonia solution and a few drops of phenolphthalein indicator. So this is ammonia with phenolphthalein. Remember, we said ammonia is a base. Dilute sulfuric acid is added to the beaker until it is excess. So that means I'm starting with a base, and then I'm going to add acid until there is lots of acid. So it's as if I'm changing from base to acid. What are the colors of phenolphthalein indicator before and after adding the acid? You should remember the colors of phenolphthalein. If I put it in a base like ammonia, it turns pink. Now, if we add acid until the acid is excess, then the color becomes colorless, or the solution becomes colorless. Do we understand this? Please remember the colors of phenolphthalein, and we also have methyl orange, and you should be familiar with the colors. Ammonium sulfate is used by gardeners as a fertilizer because it contains nitrogen. Explain why the chemical formula of ammonium sulfate is this. How do we write the chemical formula? He's saying refer to the charges on the ions. And I'm going to remind you that the charges on the ions are the same as the valency. So, do you remember what's the valency of ammonium? You should remember that ammonium ions have a charge of +1 because their valency is 1. Sulfate has a charge of -2. So if I have one sulfate, I need 2 of the ammonium ions to balance the charges. Remember that. We said when we write the formula of something, we write the valency of one under the other. So ammonium is 1, so I need 1 of the sulfate. But the sulfate is 2. It has a charge. He says refer to the charges, not the valencies. So the charges are the valency, but with a plus and a minus. So ammonium has a charge of +1. Sulfate has a charge of -2. So I need 2 of the ammonium because each sulfate has a valency of 2 or a charge of -2. Calculate the relative formula mass of ammonium sulfate. How do we calculate relative formula mass? Remember, relative formula mass is the same as relative molecular mass. It is the same as the MR. So how do we calculate the MR? We look at periodic table. Now, which numbers are we looking for? We're looking for the mass numbers. The mass numbers are the big one, and this is the main mistake that many people do. When we're calculating MR, we use the big numbers, the mass numbers of each. How many nitrogens do I have in that formula? I have, remember, what is under the hydrogen applies only to the hydrogen. So that 4 under the hydrogen applies only to the hydrogen. But what is outside the bracket applies to everything inside the bracket. So now I have how many nitrogens? I have 2. Each of them has a mass of what? Nitrogen in the periodic table, group 5, has a mass number of 14. So that means I have 2 of them. That's 14 times 2. Plus the next one. What's the next one? Hydrogen. Hydrogen has a mass of 1. How many hydrogens do I have? I have 2 times 4. Can you see that? I have 8 hydrogens times 1, that's 8. Then I have how many sulfurs? I have only 1 sulfur. Can you see that? Because that 4 after the O applies only to the O. I have 1 sulfur and 4 oxygens. So 1 sulfur, the mass is 32, plus I have 4 oxygens. Each of them has a mass of 16. When you add all of this up, it gives you the relative formula mass, or what we call the MR, or relative molecular mass of ammonium sulfate. Okay? Calculate the mass in grams of nitrogen in 1 kilogram of ammonium sulfate. Okay. Ammonium sulfate, we just calculated that its total MR is 132. That means that if I have 132 grams of ammonium sulfate, it has how many grams of nitrogen? Each ammonium sulfate has 2 nitrogen. So 132 grams of ammonium sulfate has 2 times 14 of nitrogen. Now he's saying how much nitrogen in 1 kilogram. You should know that 1 kilogram is 1,000 grams. So if 132 contains 2 times 14, then the 1,000 will contain how much? So the mass of nitrogen in the 1,000 grams of ammonium sulfate is 212 grams. Can you do cross multiplication? 1,000 times 2 times 14 over 132. Chlorine, bromine, and iodine are elements in the periodic table. Explain how the position of these elements in the periodic table depends on their electronic configuration. So when you look at the periodic table, you know that chlorine, bromine, iodine are in group 7. Chlorine is period 3, bromine is period 4, iodine is period 5. Now, he's saying how do the position of each of these elements depend on their electronic configuration. Remember, they are all in group 7, and we said the group number determines what? It determines the number of electrons in outer shell. So all of them have 7 electrons in their outer shell, so they're in group 7. And then the periods depend on what? The periods depend on the shells. So if I say that chlorine is in period 3, that means it has 3 shells. 2, 8, 7. That's 3 shells that contain electrons. Bromine would have 4 shells. Iodine would have 5 shells. So the number of the shells determine the period. Chlorine reacts with methane to form CH3Cl, that's chloromethane, and hydrogen chloride. State the condition necessary for this reaction. Okay, you have to know conditions of certain reactions. Now, this is a reaction of alkane with chlorine. Remember, when we have reaction of alkanes, remember we said alkanes are not very reactive. When they react with chlorine, what is the condition needed? You should remember, this is the reaction that needs UV light or ultraviolet radiation. If he's asking what is the name of this reaction, do you know the name of the reaction? Alkanes with halogen, this is a substitution reaction. And the conditions, ultraviolet radiation or UV light. Give the equation. He already tells you what's happening up there. Methane is CH4. You should know that methane is 1 carbon. 1 carbon alkane will have 4 hydrogens. Plus chlorine. Chlorine is diatomic, so you have to put Cl2. And he already gives you, remember that in the substitution reaction of alkanes, one of the hydrogens is removed and replaced with 1 chlorine. That is the substitution reaction. The word substitution reaction means an atom is replaced by another. So when we react with a halogen, and this can be with chlorine or bromine, one of the hydrogens is removed from the alkane, any hydrogen, whichever one you want to remove, and you replace it with one chlorine, and the other product is the hydrogen that you removed and the Cl, the other Cl of the Cl2, so the other product is HCl. The bonds in the molecule of chloromethane are covalent. Explain in terms of electrostatic attractions what is meant by a covalent bond. You remember the meaning of a covalent bond? First of all, in a covalent bond, we have electrons that are being shared. So what is holding the atoms together? Sometimes he asks what holds the atoms together, or what is meant by covalent bond. You should know that covalent bond is the strong attraction forces between what? Between the bonding pair of electrons or the shared pair of electrons and the positive nuclei of the atoms. So I have two atoms coming together. They're sharing a pair of electrons. But each atom has a positive nucleus. Remember that the nucleus contains protons and neutrons. Protons are positive, neutrons have no charge, so each nucleus is positive. And there is an attraction between each of these nuclei, the positive nucleus of each atom, and the bonding pair of electrons or the shared pair of electrons. This is what we call the covalent bond. Please don't say it's a bond between two nonmetals. That's not the definition of covalent bond. Draw a dot and cross diagram for this molecule. Okay, how do we draw dot and cross diagrams? We look at each atom. So let us take chlorine, for example. You should know that chlorine is in group 7. That means it has 7 electrons in its outermost shell. That means it needs how many? It needs 1. If it needs 1, it means it's going to share 1 with the carbon, and the carbon will share 1 with it. Now hydrogen, each hydrogen has 1 electron. It needs how many? Remember that hydrogen is the only atom that needs just another one. It needs a total of 2, because this is the first shell. And the first shell in any atom takes a maximum of 2 electrons. So hydrogen has 1 in the first shell, it needs only 1 more. So this is how you draw the dot and cross diagram of the molecule. Remember, you do not forget to write the rest of the electrons on the chlorine. So chlorine has 7 of its own. It's going to use 1 to share with the carbon, but it has the rest of the 7. So you still have 6 electrons around the chlorine. Usually students forget these electrons. Carbon is in group 4. It has 4 electrons, so it needs 4. So it's going to share 3 with the 3 hydrogens and 1 with the chlorine. Okay? Chloromethane has a simple molecular structure. Explain why it has a low boiling point. Remember that any simple molecular structure will have low boiling point. And if he says, why does anything have low boiling point? This is because there is what? Weak attraction forces between molecules that need a small amount of energy to be broken. Are we following? So, if we say, why does anything have low boiling point? Anything that has low boiling point is a simple molecular structure. And a simple molecular structure would have weak attraction forces between molecules that need a small amount of energy to be broken. Okay? Graphite is another substance that contains covalent bonds, but graphite, you should know, is a giant structure. So the diagram shows the structure of graphite. Remember, if he tells you explain the structure of graphite, I'll describe the structure of graphite, what should you say? Remember that graphite is giant 3-dimensional structure in which each carbon is covalently bonded to how many other carbons? And you see, each carbon is covalently bonded to 3 other carbons in layers of 6-sided rings. So that is the structure of graphite. Now, most covalent substances do not conduct electricity. Remember that graphite is the only substance that we talk about that is able to conduct electricity. Why does graphite conduct electricity? It has free moving what? Free moving electrons. Are we following? Each carbon had 4 electrons in its outer shell. It used only 3 of them. So each carbon has 1 electron floating around, which we call delocalized. This is free to move. Remember, when he says, explain why graphite conducts electricity, because it has free moving electrons. Explain why metals conduct electricity, also electrons, free moving electrons. But when he says, explain why any ionic compound conducts electricity, that is when you say because it has free moving ions. So you don't say ions unless if we're talking about ionic compounds. Graphite conducts electricity because it has delocalized electrons that are free to move, and we say the same thing when we're talking about metals. The table shows molecular formula of 6 organic compounds. Explain which homologous series compound B belongs to. Okay. What are the homologous series that we know? Homologous series, you should know, are groups of organic compounds. And the groups that we have are either alkane, alkene, alcohol, carboxylic acids, and esters. These are the homologous series that we talk about here. So which one is this? First of all, this is something that has only carbon and hydrogen, so you should know that it is a hydrocarbon. So it is either alkane or alkene. Now, how do I know whether it's alkane or alkene? Well, you should remember the general formula of each of these groups. So what was the general formula of alkanes? Alkanes have general formula CnH2n plus 2. That means if I have 2 carbons like B, 2 carbons means how many hydrogens? 2n plus 2. So 2 times 2 is 4 plus 2, 6. So C2H6 is an alkane because it follows the general formula of alkanes, which is CnH2n plus 2. Remember, alkenes, the hydrogens are twice the carbons. If we're talking about alkene, the hydrogens are twice the carbon because the formula is the general formula is CnH2n. But this is an alkane because it follows the general formula CnH2n plus 2. Give the letter of the compound that has the same empirical formula as its molecular form. What do we mean by each of these? You should remember, empirical formula is the simplest ratio. It's the formula that shows the simplest ratio between the atoms. The molecular formula shows the actual ratio. Now he's saying which of these has same empirical formula as molecular formula. That means it has a molecular formula that cannot be simplified further. So it is the empirical formula. So which of these cannot be further simplified? Of course, if I look at C2H4, I can simplify that. So actually A would have an empirical formula that's CH2. If I have C2H6 in B, I can simplify that. If you divide through by 2, then the empirical formula of B is CH3. What about C? What is the empirical formula for C? Well, you can divide through by 3, so that's CH2. D is C3H8. Can you simplify C3H8? You can't divide through by anything. So the C3H8 is the molecular formula and it is the empirical formula because you can't simplify it any further. Compound F exists as 2 isomers. Explain what is meant by the term isomers and include the structures of the 2 isomers of compound F. Okay, first of all, what is meant by isomers? You should know that isomers are 2 or more compounds having the same molecular formula but different displayed formula. or same molecular formula but different structures. So same molecular formula means they should be two compounds that have the same number of carbons, same number of hydrogens. So they have the same molecular formula, but they have different displayed formula. That means the carbons and the hydrogens are arranged in different ways. That's what we mean by isomers. Now he's telling me to draw the isomer of what? The isomer of F. Where is F? F is C4H10. What is C4H10? If I say what is the name of C4H10? First of all, is it alkane or alkene? Well, hydrogen is more than twice the carbon, so this is an alkane that has 4 carbons, so that is butane. So he's telling me to draw isomers of butane. What is isomer of butane? You should realize that butane is an alkane, so I can draw it like this. Now he wants an isomer. That means he wants me to draw it again in a different way so that I still have 4 carbons and 10 hydrogens, but drawn in a different way. Now, how can I draw this? We said if we're drawing isomers of alkanes, we change the chains. So instead of having the 4 carbons all after each other, I can have 3 of them after each other, and then the 4th, I put it in the middle as a substituent, what we call a substituent in the middle. So this CH3 in the middle is now called methyl. So if I were to name this, this is actually methyl propane, not butane anymore. So that first one with all the 4 carbons after each other, that's called butane. But the other one where the CH3 is in the middle, then that is called the methyl propane. Describe how compound D can be obtained from crude oil using industrial process of fractional distillation. Remember that we said the source for any organic compound is crude oil or petroleum. Now, you should know that crude oil or petroleum are a mixture of liquids. So, in order to separate them, I use the process of fractional distillation. You are required to know what happens during fractional distillation of crude oil. You are required to know the arrangement, the order in which each of these fractions is obtained, and the uses of each one. So, what is happening to the crude oil? Remember, the first thing we do is the crude oil is heated and vaporized. So, we heat the crude oil or the petroleum until it becomes vapor, and then this vapor goes into the fractionating column or the fractionating tower. In the fractionating tower, the fractions are cooled and condensed to give different fractions at different what? At different boiling points. So remember that we're separating them based on their boiling points. Now you should also remember that the one that has less number of carbons, such as D, he's saying describe how compound D can be obtained. Remember that D was something that had C4H10, so it's a small number of carbons. So the one with less number of carbons has lower boiling point and is collected at the top. So remember that refinery gases are collected at the top. These are the ones with less number of carbons, lower boiling point. They are less viscous and more flammable. As we go down, the boiling point increases until the ones at the bottom have higher boiling point because they have more number of carbons, so they are larger molecules, more viscous. You know what viscous means? It means the liquid is very thick. As we go down, more viscous and less flammable. So this is what happens during fractional distillation of crude oil. You're required to know this. Compound C can be used to make a polymer. Where is C? C is C3H6. State the type of polymer formed from compound C. Remember, C3H6, that means hydrogens are twice the carbons. That means this is an alkene. And remember, alkenes do what kind of polymers? Addition polymers, or they go through addition polymerization. If I'm starting with an alkene, this is addition, polymerization. Then he's saying, name the polymer formed from compound C. Okay, what is the name of C? Remember that C is an alkene that has 3 carbons, so C would be called propene. Now, when I form a polymer, remember, how do we name polymers? The name of the polymer is poly, the same name we started with. So if I'm making a polymer from propene, then the name of the polymer would be polypropene. Okay? Draw the structure of this polymer. How do we draw the structure of the polymer? This is how we draw propene. Can you see propene? We know that prop means 3 carbons, ene means double bond somewhere, and you need to complete it with hydrogen so that each carbon does not have more than 4 bonds coming out of it. So this is the structure of propene. Now, when he tells me to draw the structure of the polymer, how do we draw polymers? We look at the 2 carbons that have the double bond. Are you following? The 2 carbons that have the double bond, I write them with a single bond. Bond on the right and bond on the left, and I close with a bracket to indicate that this part is repeated many times, so this is what we call the repeat unit. And then I look at each carbon. The first carbon on the left was bonded to 2 hydrogens, so I draw it bonded to 2 hydrogens. Now the carbon on the right was bonded to what? It was bonded to a hydrogen and to a carbon that has 3 hydrogens. So this is how you draw the polymer of propene, which we call polypropene. Are we following? Question 7 says, dilute hydrochloric acid reacts with a solution of sodium thiosulfate to form a precipitate. And remember that this reaction is mentioned many times when we use it to determine the rate of the reaction, because sodium thiosulfate reacts with hydrochloric acid to form, can you see which one is the precipitate? He's saying state the name of the precipitate formed. Precipitate means the solid that is formed. Which one is solid? Sulfur. The S is a solid. That is the precipitate that forms. The reaction is often used to investigate rates of reaction. The diagram shows the apparatus a student uses to investigate the effect of temperature on the rate of reaction. Remember, this is the kind of experiment that we do when something is giving a precipitate. Remember, if something is giving a gas, then we use a gas syringe or a balance to determine the rate. But if something is forming a precipitate, then I draw an X on the paper, I put the solution on the X, I look through the solution, and I measure the time taken for the X to disappear, because as the precipitate forms, the solution becomes cloudy until I can no longer see the X through the solution. So this is the student's method. He poured 50 centimeter cubed of cold sodium thiosulfate solution into a conical flask, heated it to a certain temperature, so 20 for example, draw a cross or an X on a piece of paper, place it under the flask. Add 5 centimeter cubed of dilute hydrochloric acid to the flask. Look at the cross from above, record the time taken for what? Until the cross cannot be seen, or the time taken for the cross to disappear. The student repeats the experiment 4 times using sodium thiosulfate at different temperatures. He keeps what constant? He keeps volume of sodium thiosulfate constant, volume of hydrochloric acid constant. Now give 2 other factors that the student should keep constant. Remember, the only thing we want to change is temperature. So I need to keep all other factors constant, such as what? He said volume of sodium thiosulfate, volume of hydrochloric acid. The concentration of each of them also has to be constant. So I should use the same concentration of thiosulfate every time, the same concentration of hydrochloric acid, Or you could say a third one, if he wants 3 of them in this kind of experiment, you can say that we need to use the same size of flask, because if I use a bigger flask, then I will need more time for everything to be so cloudy that I cannot see the X. So when I'm comparing the experiments, I need to use the same size of flask and same concentration of each of the solutions. The table shows the student's results. The highest temperature the student uses is 60 because he thinks the results might not be as accurate at temperatures higher than 60. So just a reason why the results might not be as accurate at temperatures higher than 60 degrees Celsius. If you look at the time taken for each experiment, when we did it at 20, it took 400 seconds. At 30 degrees Celsius, it took less. At 40, less. At 50, less. At 60, less. That means that at any temperatures higher, then the time will be what? The time would be very small. The reaction is too fast. The time will be too short, so there will be larger error in measuring time. So usually at very high temperatures, it will not be enough time for him to determine or to start and stop the stopwatch. The student wants to compare the rates of reaction at different temperatures. He uses this formula to obtain a value for each rate. Remember that he was measuring time, but if we want to calculate rates, he's telling me that he will calculate rate by using this equation. Rate is 1 over time. I want you to notice that if the time is big, then the rate is small. If the time is small, then the rate is faster. Okay, so faster reactions will take less time. Plot the values of the temperature and rate of reaction on the grid. I hope you know how to plot graphs by now. You should plot using very small X's or dots with a circle. And then he's saying draw a curve of best fit. So your curve should look something like this. Use the graph to determine a value for the rate of the reaction at 45. So I have drawn the graph. He wants me to get from the graph the value of the rate at 45 degrees Celsius. So I look, where is 45 degrees Celsius? That's the one down there between 40 and 50. I go up to the graph, go horizontally, and he says, show on the graph how you obtained your answer. So you have to draw these lines from 45 up to the graph and then horizontally to see what is the rate. And you can see from your graph that the rate would be 0.017. Calculate the time that it would take for the cross not to be seen at 45. Well, we found that the rate is 0.017 and he gave me an equation. Rate is 1 over time. So how do I get time from that? You should realize that time will be 1 over rate. If rate is 1 over time, then time is 1 over rate. So 1 over what we got from the graph, this gives me the 58.8 seconds. Describe the relationship between rate and temperature. Can you see the relationship between rate and temperature? Well, as the temperature increases, what happens? As the temperature increases, the rate increases. Explain in terms of particle collision theory the effect that increasing the temperature has on the rate. Why is it that when we increase the temperature, the rate increases? You should be able to explain this with respect to collision. Please make sure you mention collision somewhere. So you should know that as the temperature increases, what happens is the particles gain more kinetic energy. And please don't mention more kinetic energy unless if we're talking about temperature. So if he's saying more concentration or more surface area, that has nothing to do with kinetic energy. Kinetic energy increases only when we're talking about temperature. As temperature increases, The particles gain more kinetic energy. Now, when they gain more kinetic energy, that means they will start to move faster, collide faster. So there will be more successful collisions per minute. So you can say more frequent collisions or more collisions per minute, and more particles have energy higher than activation energy. Remember that activation energy, we said, is the minimum amount of energy needed for a reaction to occur. So if you increase the temperature, then more particles have energy higher than activation energy, so more particles will collide successfully. Successfully means collide and do a reaction per minute. So we have more frequent collisions or more successful collisions per minute. Question 8 says a student uses this apparatus to investigate the heat change when a salt dissolves in water to form a solution. This is the student's method. Add 50 centimeter cubed of distilled water to a polystyrene cup. Record the initial temperature of water. So he put 50 centimeter cubed and recorded the initial temperature. Now add a known mass of solid anhydrous copper sulfate to the polystyrene cup. Stir the solution until all the solid has dissolved. Record the maximum temperature of the solution. The first question says, name the piece of apparatus the student should use to add the distilled water to the polystyrene cup. What does he need to add? He needs to add 50 centimeter cubed of distilled water. When we say 50 centimeter cubed, that means we don't need it to be really exact. He did not say 50.0. If he said 50.0, then we would say we will need a burette or a pipette to add the water. But he said 50. Just 50 means about 50, and that means we can use a measuring cylinder. Remember, measuring cylinders are not as accurate as burettes. We need a burette if he's saying he needs 50.0. But here it's just 50 centimeter cubed, so we can just say measuring cylinder. The student stirs the solution to help the solid dissolve more quickly. So just another reason why the student stirs the solution. He's trying to stir it and he's trying to measure the temperature. So if he stirs it, the solid will dissolve more quickly and he will distribute the heat evenly so that all the solution has the same temperature. So usually when he says, why do we stir? To distribute the heat evenly so that all the solution has the same temperature. State the color of copper sulfate solution. You should know what is the color of copper sulfate solution. You should know that copper sulfate solution is blue. It's a blue solid, and when it dissolves, it forms a blue solution. The diagram shows the temperatures in one experiment, and he says, complete the table. Now, the common mistake here is putting the initial instead of the maximum. He usually starts with maximum. Which one of these is the maximum? You have to look. So the maximum is the one on the right. And then you should read it correctly. So how do you read this? This is somewhere in between the points. So this is 27.3. Can you see that? Each of these small lines is 0.2. Because you have 5 of them, 25, 26, 27, this is 27.3. And this is the maximum, not the initial. Now, where is the initial? The initial is the one that reads 24.4. Can you see that? It's exactly at the one of these lines, which is at 0.4. The increase in temperature, of course, will be the difference. So 27.3 minus 24.4, that is the increase in temperature. In a second experiment, when a student dissolves the anhydrous copper sulfate in 50 centimeter cubed of distilled water, the increase in temperature is 3.3. So he's telling me that the temperature went up by 3.3. Show that the heat energy change in this experiment is approximately 700 joules. How do we calculate Q? Remember that Q is the quantity of heat or the heat energy change, And you should know that Q is MC delta T. Now, what is M and what is C and what is delta T? You should realize that M is the mass of the solution or the mass of the water. And if he says 50 centimeter cubed, that is the same as 50 grams, because density of water is 1. And he already gives you that the mass of 1 centimeter cubed of water is 1 gram. So the volume of water is the same as its mass. If he says 50 centimeter cubed, that is 50 grams. Times C, you should realize that C is the specific heat capacity, and he gives it to me as 4.2. Sometimes we use it as 4.18, but if he gives it 4.2, then that's what you use. Times delta T, and delta T is the temperature change, and he already gives me that the temperature change is 3.3. And what comes out from this equation is in joules. So Q calculated like this will come out to be 693 joules. So that is approximately 700 joules. So that is correct. In this experiment, the student uses 1.7 grams of anhydrous copper sulfate. Now calculate delta H. How do we calculate delta H? You should know that delta H is Q over N. So Q is what we just calculated. And N is the number of moles. Number of moles, you should realize, is mass over molecular mass. So where is the mass? The mass is 1.7 grams over the molecular mass. He gives it to me. Please, if he gives it to me, then that's what I use. Don't waste time and sit down and calculate it. So the MR of the copper sulfate, he gives it to me. So that means that the number of moles is this. And that means that delta H is Q over N. The Q we got 693 over the number of moles that we got. This is in joules. He wants it in kilojoules. Remember, in kilojoules, that means I'm going to divide that by 1,000. So this is 64.8. Now, remember that delta H must have a sign. How do I know the sign? In the previous part of the question, he told me there was an increase in temperature. That means temperature went up. When temperature increases, that means we're talking about exothermic reaction, and exothermic reaction, the delta H is negative. And that means that the value that I have is minus 64.8 kilojoule per mole. Notice, please, that he wants it in kilojoule, so don't leave it in joules. Are we okay? Another student does a similar experiment but uses hydrated copper sulfate instead of anhydrous. Do you know the difference between hydrated and anhydrous? You should remember that the word hydrated means it has water of crystallization. That means the crystals have water in them. Anhydrous means the crystals do not have water. The table shows his results. Explain what the results show about the type of energy change that occurs. Remember, if he says what is the type of energy change, it is either exothermic or endothermic. We said the other one was exothermic because the temperature went up, so we put a minus sign for the delta H. Now here what is happening? The initial is 23.8. The final is 22. So what happened to the temperature? It went down. So what kind of energy change is this? This is endothermic because the temperature decreased. Okay? Sodium hydrogen carbonate is also known as baking soda. Baking soda can be used to make cakes increase in size in an oven. This is the equation for the reaction. What type of reaction is this? Well, let's see what is happening here. I'm starting with sodium hydrogen carbonate and I'm heating it, so it is breaking up into several compounds. When something breaks up to give several products, this reaction is called decomposition. Specifically, if we're doing it by heat, it would be called thermal decomposition. Suggest why the reaction makes the cakes increase in size. Well, you can see that the reaction is producing what? It's producing carbon dioxide gas. Now the carbon dioxide gas will make the dough or the cakes increase in size or swell up. So it is increasing in size because the carbon dioxide gas is given off. A student uses this apparatus to investigate the reaction that takes place when sodium hydrogen carbonate is heated. So he has the sodium hydrogen carbonate in a crucible and he's heating it. This is the student's method. Weigh a crucible, record the mass. Add some sodium hydrogen carbonate to the crucible and reweigh. So he weighed the crucible alone and then the crucible with the sodium hydrogen carbonate and he recorded the mass. Heat the crucible and contents for 5 minutes. Then allow it to cool and then weigh and record the mass. Heat the crucible again for another 3 minutes. Then allow it to cool, weigh and record the mass. Give a reason why the crucible and contents are heated for a further 3 minutes. He heated it for 5 minutes. Why is he heating it again? Remember, when we do this kind of reactions, what we're trying to do is we want to make sure that the reaction has finished. So how do I know that the reaction has finished? If there is no longer any change in the mass. So we keep heating and reweighing. Heat and reweigh until we reach constant mass. And this is to make sure that the reaction has finished. The student considered using a lid on the crucible. So he said, with this crucible, I should put a lid. Suggest an advantage and a disadvantage of using a lid on the crucible. What would be the advantage? If I cover this, remember, I'm trying to heat a solid. If I leave it without a cover, then some of the solid may be lost from the crucible. So when I cover it, the advantage is it prevents loss of solid during heating. But then actually I shouldn't cover it, because if I cover it completely, then the carbon dioxide gas will not be able to escape. This is something that is breaking up to give carbon dioxide gas, and this gas needs to escape, so I cannot really cover it completely. The table shows some of the results. Calculate the mass of sodium hydrogen carbonate that the student uses. Well, we have mass of crucible and sodium hydrogen carbonate, and then mass of empty crucible. So how do I get the mass of the solid? It's just the difference between them. Crucible plus solid minus the empty crucible. So this means I have 3.25 grams of sodium hydrogen carbonate. Using this equation, calculate the maximum mass of sodium carbonate that could form in the student's reaction. So, I have a certain mass of the sodium hydrogen carbonate that I started with. I should be able to use it to calculate how much sodium carbonate should I get. How do we do that? The first thing is, get the number of moles of the sodium hydrogen carbonate. Number of moles is mass over molecular mass, and he already gives me the molecular mass. So I get the number of moles of NaHCO3. Then I look at the equation. I relate it to the sodium carbonate. The equation tells me that if I have 2 moles of sodium hydrogen carbonate, it gives me 1 mole of sodium carbonate. That means number of moles of sodium carbonate should actually be half. Can you see that? Of NaHCO3. So if I have this number of moles of sodium hydrogen carbonate, then the number of moles of sodium carbonate formed should be half of that. So divide by 2. And that means I can get the mass from that number of moles. How do we get mass? Mass is number of moles times MR. So the number of moles that we calculated times the MR of the sodium carbonate, and that means that I should end up with 2.05 grams. That is what we call the theoretical yield, what we calculated that should be obtained. In a second experiment, the student uses a larger mass of sodium hydrogen carbonate. She calculates that she should obtain 4.8 grams. So when she did the calculation, as we just did, she found that she was supposed to get 4.8 grams. Now, she actually obtains 4.2. So what is the percent yield? How do we calculate percentage yield? The percent yield is what she actually got, so she got 4.2, over what she calculated, what she should have obtained. She should have obtained 4.8, but actually she obtained only 4.2. And that means her percent yield is 87.5. So the actual over the theoretical, which we calculate from the equation, times 100, that is how we get percent yield. Other than spillage, so just a possible reason why the student's actual yield is less than expected. We said always when we do an experiment in the lab, what we get is usually less than what we actually calculate to get. So we always get less than the theoretical. Why? Either the original compound was not pure, so actually I did not have that number of moles that I calculated, or not all of it was decomposed. The table gives information about some lead compounds. When a sample of red lead oxide is heated, it changes into yellow and a gas forms that relights a glowing splint. He gives me the appearance of all the lead oxide. So he's saying if I heat the red lead oxide, can you see the red one? The red one is Pb3O4. So the red lead oxide, he said it should give me a yellow. Which one is yellow? Yellow is the lead 2 oxide. Plus a gas that relights a glowing splint. You should remember the tests. Which gas relights a glowing splint? That is oxygen. Remember, he wants word, so you give him word equation. A sample of one of the oxides of lead contains this percentage of lead and this percentage of oxygen. Show by calculation that the sample is PbO2. That means calculate the empirical formula. How do we calculate the empirical formula? You write the percentages. And then the first thing you do is what? Divide by molecular mass or the atomic mass. He already gives me that the atomic mass is 207 for lead and 16 for oxygen. So we divide the percentage of lead by 207 and get a number, and the percentage of oxygen by 16. Now I look at these two numbers and I should divide by the smallest. So the smallest is 0.418, so I divide through by 0.418. I get a ratio of 1 to 2, and that means that my empirical formula is PbO2. Red lead oxide reacts with warm, please note the warm, dilute nitric acid. First of all, complete the chemical equation. So in parts of it, he wants the state, and in parts of it, he wants the balancing. So first of all, for the Pb3O4, he wants the state. If you go back to the table, that was a solid. Now, what is the state of nitric acid? You should realize that all acids are aqueous. Then we balance. How many lead atoms do we have before the arrow? We have 3 leads. So I need 3 leads after the arrow. I already have 1 with the PbO2. So that means I need 2 here, so that I have a total of 3 Pb after the arrow. Now, how many hydrogens before the arrow? Before the arrow, I have 4 hydrogens. That means I need 2 times 2 in order to have 4 hydrogens. And if you count now the oxygens, you'll find that they are balanced. Last question. A student is given a sample of solid red lead oxide and some dilute nitric acid. Describe how the student could obtain a pure dry sample of lead nitrate crystals. So we're trying to prepare salts. Remember, we had 3 methods of preparing salts. We could either use titration or neutralization or precipitation. Now, which one are we going to use here? We're starting with a solid, and that means what I'm explaining is basically the method that we call neutralization, in which I should put the solid on the dilute nitric acid. And please remember, in the previous question, he said it reacts with warm dilute nitric acid. So that means I should heat the nitric acid, add the solid, stir until excess solid remains at the bottom of the beaker, and then I do what? Filtration to get rid of the excess solid, and then I take the filtrate and do crystallization. So that's what we're supposed to explain. So when you have this kind of questions, please think of what you're supposed to explain and then write it. So add solid red lead oxide to warm nitric acid, or you can tell him at the beginning, warm the acid and then add the solid. Stir until excess solid remains in the beaker. Filter the mixture through filter paper and funnel. Please be specific and explain exactly how you do everything and the apparatus that we use. Heat the filtrate to point of crystallization, cool to form crystals, filter the crystals, wash with a few drops of distilled water, dry between filter papers because he wants pure dry sample. So that's how you explain it. And we are at the end of the paper. I hope you understood everything. Please share with others so that many of the students could benefit, and keep listening to these videos. Thank you for listening.